G'day guys, like I mentioned yesterday, we're going to be going through some compositional area problems. So compositional means it's composed of, or it's made out of different shapes. So our first one is a nice little simple one. I want the shaded area, so it's this rectangle and we've got a circle cut out of the middle of it. So our area, so our total area, so like most videos you can pause and give this one a go, but it's a 6 meter by 4 meter rectangle and I've got a circle cut out of it and the circle is touching the top and bottom of this rectangle. So total area is going to be rectangle, spellings are gone today, rectangle, take away the circle. So that's going to be, the area will be the area of the rectangle, 6 by 4, take away the circle. Now, the area of a circle is pi times r squared. So what is r? Well, r is half of that diameter. So that's 2 meters. So pi times 2 squared. So it's going to be 24, take away. I'm just going to use 3 for pi today. 3 times 4, so it's 24 minus 12. We have 12. Units are meters and its area, so it's meters squared. So a few lines are working, but it's basically getting the understanding that it's the rectangle, take away the circle. Cool. What I want now is the total area of this shape. So I haven't drawn it particularly well, but it's basically a triangle with a circle on each of its sides. So it's a 10 by 8 by 6 triangle. And just notice that that's just a doubling of the 3, 4, 5 right angle triangle. So if we want the area of this, total area, well, it's going to be the triangle plus half circle plus half circle plus half circle, isn't it? So it's just the triangle area plus each of those half circles. So that's going to be, the triangle is half base times height, half times base times height, plus, and now we've got, let's do this one first. So we'll go biggest to smallest. So I'm going to go half circle, so it's plus a half of pi r squared times pi, and r is 5 times 5 squared, plus a half for the medium circle times pi, because it's a half of the circle, so it's half of the area, so half of, and it's going to be 4 squared, plus a half times pi times, and then a radius of this is 3 squared. So what I'm doing here is these are the areas of the circle, of the circles, and then I'm just halving them because we've only got half of the circles, and I'm adding them all up. So what that's going to look like is, I can put this all into my calculator in one big step and go a half times 6 times 8 plus a half times pi times 5 squared is 25, plus a half times pi times 4 squared, which is 16, plus a half times pi times 3 squared, which is 9. So I can do that all in one big calc because it's already in bed maths, right? It's going to do the multiplication before it's going to do addition. And so we get 102.5. Look at my units, they're in centimeters, and its area, so it is squared. So it's pretty tricky, but like I said, these composite area problems can be quite challenging. So for this one, it was meant to be a square, but I drew my circles first, and so it skewed it. But imagine that this is a square and we want all of this shaded area. So this might actually be quite useful if you were creating, maybe if you were calculating the area needed of some concrete with circular pavers, or say it's a drink holder, right, and you're putting your cups in, what's the amount of plastic you're going to need, or maybe your compostable plant-based alternative to keep it green, to keep your cups in, right? So what we need is we're going to be taking the square, so the total area. So notice how I solve these problems. I just look at what I'm going to have to do first before I actually do any maths. I'm going to be taking the square, and I'm going to be taking away 4 circles. So that's going to be the square, which is 100 by 100 millimeters squared. Take away 4 of those circles. I'm just going to put this area of the circle in a square bracket. So that's pi times r squared. So I need to figure out what r is. Well, this is 100 all the way through. So all the way through 1 is 50. And so the radius of 1 is 25. So it's pi times 25 squared. And that's my working. There's my square. So 100 by 100. What's that? Is that 10,000? It is, isn't it? Because it's kind of like a hectare. So 100 times 100 is 10,000. Take away 4 times pi times 625. Right, it's 4 times pi times 625. And so that's going to be 10,000 take away. And I'm just going to make pi 3 for this one. So that's going to be 4 times 3 times 625, 7,500. And so our total area of this shaded bit is going to be 2,500. What are my units? Millimeters. And it's an area, so it's squared. There's my answer. Okay, so this problem is looking pretty interesting. So you might want to just pause the video and give that one a go. But I'll read you out all the measurements just to be safe. So that's 60 centimeters along the top. We have a 40 centimeter diameter across that half circle. The distance from the base of that circle to this point here is 25 centimeters, and our total height is 40. So I want the area of this entire shape. So total area. So you could pause that, give that one a go. Well, that's going to be a trapezium. Hopefully I spelled that one right this time. And that's going to be plus this rectangle, take away the half circle. So I actually like to I do this all in one big move, but you can break it down. You could go trapezium area equals, figure that out, rectangle area equals, figure that out, half circle area equals, figure that out, and then do the appropriate addition subtraction. But the area of the trapezium, well, that's going to be the long side plus the short side divided by 2 from my previous video of that chute. I don't have to put that in brackets because I put it on top of the line, but I'm just going to be safe. Multiply that by the height. So the height is going to be this distance here, isn't it? So it's going to be 40 take away 25, so times by 15. That's our a plus b over 2 times height, and that's our trapezium. We're then going to add that to the rectangle, which is 25 by 40. And then we're going to take away the half circle. So half the area of this thing. So half of pi r squared. Okay. So I might need to break down this this problem. I'm going to do 60 plus 40, which is, I can actually do that in my head, can't I? That's 100 over 2 is 50, and 50 times 15, I'll just be safe, is 750. So the area of that trapezium is 750 centimeters squared. I'm going to add that to the rectangle. 25 times 40, 1000. I should have known that one. Okay, that's 4 times 25 is 100, and then I've got another 0. And I'm going to take away a half pi times 20 squared. I used 3 over here, so you actually use pi this time. 0.5, which is a half, times pi times 20 squared, and that's 628.3. Okay, and now it's just, I can add that up. So I've got 1750. And because I'm using the calculator, my last answer was that number. So I've just added those in my head, and I'm taking away the answer from that previous problem. So total area is 1121.7. It's going to go to 1 dp, and that is centimeters squared. And there we have it. We have the area of that unusual shape. 2 more problems for us today. Let's have a look at calculating the area of a donut. Okay, so what we've got here is the radius of the big circle on the outside is 20 centimeters, and the radius of the little circle is 12 centimeters. So the total area, that's going to be equal to big circle, right? Because it's going to give us the complete area enclosed within this line. Take away the little circle or the smaller circle. Okay, so it's going to be the big circle, take away this bit on the inside. So that's going to be pi times r squared, take away pi times the smaller r squared, 12 squared. So I use 3 this time. So this is 3 times 400, take away 3 times 144. And so that's 1200, take away 432. And our total area is 768 centimeters squared. Awesome. So that is how you calculate a donut. You take the big circle, so the total area within that large circle, and you take away that part that's on the inside. What I've got here is a upside down part of a nuclear symbol. I accidentally drew it with the 2 on the bottom and the 1 on the top, but I believe it's the other way around. So what I've estimated is I've estimated that each of these 3 parts is just part of a donut, and it's 60 degrees. So it's cut from a 60-degree angle. So what we're going to be doing is if each of these is 60 degrees, then all 3 of them must add to 180. So in fact, they would actually create half of a donut, wouldn't they? So I don't know if you can see it there, but I've said it's 10 centimeters from the invisible center to the outside of the large one, and I've got 3 centimeters from the invisible center to the inside of those symbols. So what we're going to be calculating is a large circle, take away a smaller circle, and then we're going to take half of that total area, because 60 plus 60 plus 60 is 180. So imagine that if we put these all together, it would give us a shape kind of like that, right? A half donut. So let's do big circle. This is a bit more complicated, so I'm just going to break it down. So the large circle would be pi times r squared. So that's going to be 314 centimeters squared. Small circle, well, that's going to be pi times the smaller radius squared, which is 3. I'll need a calculator for that one. Pi times 9. Oh, shift pi times 9, 28.3. And so I'm going to have to take them away and then divide by 2. So total area is, it's just like before, we're calculating a donut, and then half of it is missing. Okay, so we've got 1, 2, 3 out of the 6 missing. So we have half of what that donut area is. So 314 minus 28.3, and then we're going to half it. So that's going to be 314 minus 28.3. Divide that by 2. We have 142 point, I'm going to call that 9 centimeters squared. That was pretty tricky, but we got there in the end. Nice.